Right, good day. Molweni sawubona tumelang agenda sanibonani ninjani. Namaste, salam alaikum, bonjour, comment allez-vous? Par favor, or por favor, my apologies. Right, and I hope you enjoy this definition of a log and general rules of logs needed to plot functions. Right, I'm not doing the laws of logs, all of them. This is just for caps, but if you want a lesson on logs, I would do one for you gladly. Right, so per definition, for a greater than 0, a not equal to 0, and a not equal to 1, x greater than 0, log is written, y equal log, a there represents a base, and that represents my value. It's just a different way of expressing my exponents where x equal ay. So you see my base and the base is still the same, but x and y change places. So to put it to you in simple terms, if I had to solve 3 to the power 2, I would get an answer of 9. But if I have an answer of 9 and I have to find the exponent, then log same base, 3, the 9 and the 2 change places, 9, and I would get an answer of 2, stating that 3 to the power 2 would then give me 9. Look here again, x to the power 4 equals 64. In log format, take the base down, 64 and 4 simply change places. Alright, so 4 to the power 4 would give me 60. Now I'm lying here, 4 times 4, 16. Log x to the power 64 would equal 4. They simply swap places. 7 to the power 3 equals 343. So log 7, swap 343 and 3. And that's 7, 343 then would give me 3 as an answer. And p to the power 4, 81. Again, you see there the base, and then simply say the x and the y swap places. 81 goes by log and 4 goes there. So I hope you follow and you understand what I've done here, because we're going to be using this to plot as well as to find equations of inverses. Alright, so given y equal to log 3x. Right, now we're going to look at how to find the coordinates to plot it. Alright, so I have base 3. No matter which base I have, if I put the value 1 with that base, it will always give me an answer of 0. So if x equal to 1, coordinates 1 and 0. X equal to 3, you see now I've made a base. I've made the base and the value the same. If that's the case, we'll always get an answer of 1. So therefore coordinates 3 and 1. And everything else that we're going to solve now, we're going to try to get it to the value 1. So if x equal to 9, I have log 3, 9. And I've used 9 because I can express it with base 3. So that becomes 3 squared. The rule states I can take 2 to the front, any exponent there. So log 3, 3 is 1. 1 times 2 gives me 2. And I have 9 and 2. Alright, and here in the fourth one, x equal 1 over 3. I have log 3, 1 over 3. Can express that with base 3. So if I take 3 up the division line, it becomes 3, negative 1. The exponent of that value can be moved in front of log. So that becomes negative 1. Log 3, 3. Base 3, value 3. So that gives me 1. 1 times negative 1 stays negative 1. Coordinate 1 over 3 and negative 1. So hope you follow and you can see how I found the coordinates. Very important, we have exam questions structured around this concept. Right? I plot now, I have 1 and 0, 3 and 1, 9 and 2, 1 over 3 and minus 1. So 1 and 0, there x is 1, y is 0. There x is 3 and y is 1. We go further, 9 and 2, etc. But we plot. That is the shape of the log graph, and there's different ways it shapes, but you'll see that once we solve various problems. Right? Hope you liked and enjoyed the lesson. Please share and subscribe. Right? I wish you nothing but the best.